last video, we talked about two-slit diffraction, and it's just like having two sources, and this equation, which we should be pretty familiar with, we can use to say find the angle between the central maximum and another maximum. Now, it turns out that this equation works for two sources or 3 or 1 million. Doesn't matter how many sources you have. All right, and there's a thing called a diffraction grating. And these split light into millions of sources. So you might see a problem like this. Light with a wavelength of 4 times 10 to the minus 7th meters is incident on a diffraction grating. With 300 lines per millimeter. What is the angle between the central max and the second order max? Okay, so we're going to use this equation. We know that m is 2 because it's second order max. We have the wavelength. We don't have this d, but we're going to get it from this 300 lines per millimeter. So we're going to start out there. We're going to find d over here. So there's 300 lines per millimeter. Now, I want to know how many lines there are per meter, and there's 1,000 millimeters in a meter. So if there's 300 lines in each little millimeter, there's going to be 1,000 times as many in a meter. So that's 300,000 lines per meter. Now, if there were 2 lines per meter, there would be half a meter between each one. It's just reciprocal. So D is just going to be 1 meter over 300,000 lines, which is going to be, if I divide that out, 3.3, repeating, times 10 to the minus 6 meters. Now I can use that and plug it in here. M was 2. Wavelength is 4 times 10 to the minus 7th. And that's going to equal, D we now know is 3.33 times 10 to the minus 6th sine theta. When we solve that, we'll get an angle of 14 degrees. So this part of the problem is the same. There's just one step you have to do before that, and that is to find how many lines you have per meter.